today is our last day of Unit 3.
No. Really?
I know, it's devastating. Today we get to talk about Cpctc. Corresponding parts of congruent triangles are congruent. Okay? So we can use any of our 5 theorems, and once we get the fact that, hey, our triangles are congruent, we can use Cpctc to prove that parts of our triangle are indeed congruent. So how many pieces did we need to prove congruence?
3.
We needed 3, right? So how many pieces total are in our congruent triangles? 6. So if we only need 3, corresponding parts will help us find the remaining 3 out of the 6. So when we're asked to prove that parts are congruent, we're going to use, we got to first prove our triangles are congruent. Yes, sir. So we're just going to do a bunch of proofs. So if you look at this, so you guys have the blue written in there, correct? Yeah. So if you look at this, and we'll go ahead and we'll do like a little rewind flashback to yesterday. What is different about our statements today versus the ones we've been doing for the past 2 weeks?
The triangle is not at the end.
The triangle is not at the end. We're still proving our triangles are congruent, but now it's not our final step. Once we've got our congruent triangles, we can then turn around and prove that the other pieces that exist that aren't necessarily congruent, they themselves are now congruent because our triangles are congruent. Right, so here we go. Number 1, AB is congruent to AD. Let's go ahead and mark that on our diagram. So AB to AD, a little single tick mark. What's our second piece? BC to DC. So BC to DC. And then last class asked, hey, coach, we see we're smart, we're intelligent, we know that that AC is going to be congruent. Can we go ahead and mark it now? And what do y'all think?
No.
Absolutely. Go ahead. Y'all know that that reflexive relationship will always be congruent. You can mark it if you want to, but you don't have to. So if you want to mark reflexive, if you want to mark vertical angles from the jump, go for it. Ain't nobody gonna stop you. All right. Except for Go Guardian, correct. Go Guardian will indeed stop you. All right, number 1. How did we know AB was congruent to AD? Given. What about BC being congruent to DC? That was also given. What about AC is congruent to AC? How do we know that? Reflexive, correct. Why is it the reflexive? All right, how did we know AC was congruent to AC? It's reflexive. Why is it reflexive? It is a shared side. Good. So reflexive POC because it's a shared side. All right, how many pieces did we need to be able to show congruence? 3. Do we got our 3? Statement 1, side or angle? Side. Statement 2, side or angle? Side. Statement 3, side or angle? Side. So why are our triangles congruent? Side, side, side. So the last couple weeks, this is where we stopped. Okay, but if we look at our prove statement up here, it doesn't, well, it needs the triangles to be congruent, but it's worried about proving angle BCA to angle DCA. So this angle right here. Prior to showing our triangles were congruent, we did not know that. But now that our triangles are congruent, are those two angles themselves congruent? Yes. What makes them congruent? Because the triangles are congruent, what do we call that? Cpctc. And on Math Lab, they'll hit you with one of these. I don't know why, but they're weird. Cpctc. They just put the O and the A in there. Do you like that better?
They're making sure all the letters go
Not to right.
I can scroll up a little bit. Oh, Cpctc. Yeah. All right, let's go to the next page, down to number 4. Y'all's blue was in there, right? Yeah? Good. All right, so JM bisects KJL. So what does it mean for this line to bisect this angle? That means it cuts it into two congruent angles. So those two angles are indeed congruent. Yep. That way we can get to the homework. I know. So Brock doesn't have a cow on me. Okay, and then it tells me angle JMK is congruent to angle JML. So JMK is congruent to JML. Is there anything else y'all want to mark up before we move on? You want to mark up the shared side? Okie dokie. So we can highlight that part.
How did you know that the J was like the one
The one on top?
and on bottom? How do you know that?
Well, so the one on the bottom is this given here. That's the JMK to JML. The yellow is what we got when this was bisected. So when this large angle was bisected, it means it cut it in half, which made those two congruent segments, or them two congruent angles. All right, how did we know JM bisected JKL? They told us. So what created KJM and LJM? What created that congruent angle relationship? The bisector created the relationship. So we're going definition of angle bisector. Nothing else we can pull from that thread? What about JMK is congruent to JML? They told us. Otherwise, we had no idea. JM is congruent to JM. Why reflexive? Because it's a shared side. So reflexive property of congruence, and it's reflexive because it's a shared side. Does that only work for sides? What else could it work for? Shared angles. Okay, so let's go through and see if we got our three pieces we need to angle or side. Sure. It can be on top of itself. I mean, that's real. KJM is congruent to L. Is that an angle or a side? Angle. JMK to JML, angle or side? That is an angle. JM to JM. That is a side. So which two theorems could we possibly use? Angle, side, angle, or angle, angle, side. And what's the biggest difference between those two? Good. So an angle, side, angle, the congruent side is between our two congruent angles, but an angle, angle, side is not. And another way you could say it is if I've got angle, side, angle, or I've got angle, angle, side, if I look at the one on the left, how many A's does the S touch? 2. And I look at the right, how many A's does the S touch? 1. So if your S is touching 2 A's, it's angle, side, angle. But if your S is only touching one of our congruent A's, it's angle, angle, side. What is our situation here? Remember, we look one triangle at a time. Does our blue segment touch both of the congruent angles? Yep, look at the top as well. Does our blue segment touch both of the congruent angles? Yes. So which theorem proves these are congruent? Angle, side, angle, or angle, angle, side? Angle, side, angle. Okay. So now that we know that, why is JK congruent to JL? So if we go back up here, why are these two segments congruent now? Because my triangles are congruent, all the corresponding parts are congruent. So C, B, C, T, C. All right, one more. Uno mas, before we have a dadgum aneurysm in the back. It looks like it might be. BC is parallel to EF. What did I tell you guys about parallel? What should we think when we hear parallel? Alternate interior or corresponding. It's probably one of those two relationships. How do we look for alternate interior angles? All right, well, let's find out as we work through. And then D is the midpoint of BF. What does it mean for D to be the midpoint of BF? So that means that BD is congruent to FD. It is the transversal though, ma'am, you were correct. I don't think you're a ma'am. I know. All right, so why is BC parallel to EF? It's given. Our next statement is B is congruent to F. So B is congruent to F. How did they get that? It's not given. What happens if I were to draw a Z? Alternate interior, right? So we know if we can draw that Z and our corners are congruent, that it's what? Alternate interior angles. Fantastic. Alternate interior angles are always congruent. What about D being the midpoint? How do we know that? It was given. If they didn't tell us that, could we assume it? No. No. Why is BD congruent to FD? Definition of midpoint. So they've got a couple of directions they can go here. Let's see which way they chose to go. BDC is congruent to FDE. So they went BDC, so double hoop, is congruent to FDE. Where'd they get that from? That is vertical angles. What do we know about vertical angles? Vertical angles are always congruent. Very good. Vertical angles. Okay. So we've got, do we got our three pieces? 2 is a what? Angular side. Angle. 4 is angular side. 5 is angular side. Angle, side, angle. So it's either got to be one of which two? Angle, angle, side, or angle, side, angle. Which one is it here? Why? The side is between our two congruent angles. Remember, guys, we look at it one at a time. Our yellow side is between the red and the blue. Our yellow side is between the red and the blue. So why are our triangles congruent? Angle, side, angle. So because our triangles are congruent, why is ED congruent to CD? Cpctc.